Hey, hello everyone, and welcome to Live Code Tuesdays. I'm Sohan Maheshwar. I'm a dev advocate at Fermyon, and I'm joined by Radu, CTO at Fermyon. So, for those of you all joining in for the first time, this is Live Code Tuesdays, where we show you how to build using Spin and WebAssembly. And right now, we're building a serverless AI inferencing app. We started building this a couple of weeks ago, and Radu, maybe you can give us a quick recap of what we're building, what we've built so far, and what we're going to build later today.
Sure. Hello, everyone. Okay, let me share my screen for a second. There we go. So last few weeks, we started building an application with Spin, which is our open source tool for building serverless applications using WebAssembly. So we're building a really simple chat application. You can find it on my GitHub. But essentially, we're building a sort of chat GPT-like application that can run entirely using Spin locally, or we can deploy to Fermyon Cloud. And the idea here is, I think we have to also start the app before I can show it. But the idea is to be able to use the new inferencing features in Spin to send messages to Llama 2 and have Spin generate inferencing requests and handle inferencing requests using the Llama 2 inferencing model, and basically have a sort of chat-like application. So if I ask it questions, for example, what is a bird, basically format the message in a way that Llama 2 chat can generate responses to my questions. So that's what we've built so far. The application has like conversation history that you can load, and it is able to keep the context of the conversation. So if I continue the conversation, it continues to have the context of what I'm talking about, and we'll see in a second where all of this is stored and how all of it works. So just a brief high-level overview of what it is that we're actually building. So we have the web UI for our application, what we just saw right here. And then we have a couple of endpoints built using a Spin application. Both the UI and the API running in a Spin application. The API endpoints for the backend are the endpoint to generate an inferencing based on the conversation history up until that point. And then the option to get the history. So if I refresh the page, I can basically fetch all of the conversation history from the key value store, and then another API endpoint to delete the conversation ID. So if I clear the conversation ID, all of that is gone. There's no more data associated with my app. So what we want to build today is a new API endpoint that takes the conversation history up until a certain point, and generates a summary for our conversation history up until that point. And we want to display that summary like the title for our web page. So we're going to write Rust this week, and we're going to basically go through the process of creating a new component in Rust, and writing a handler in Rust, and accessing the key value store, and sending inferencing requests from the Rust using the Rust API. And so this week, I'm really looking forward. It should be a lot of fun.
Nice. And Radu, I think the cool thing is so far everything that's been built has used like JavaScript and TypeScript, correct?
Correct. The API we've built so far was written in JavaScript, TypeScript specifically, using the SDK, and then the UI obviously was JavaScript. So today we're gonna write some Rust, and I'm pretty happy about that.
Yeah, I think we've had some healthy debates, let's say, in the comment section about which one's better, like TypeScript and Rust and all of that. Feel free to continue those debates right now in the chat, folks. I can see Holy Odin says hello everyone in the chat. Thanks for joining in again, Holy Odin. You were here last week as well, so very cool that you're here this week too. And yeah, Radu, over to you.
Cool. So as I mentioned, we have a Spin application. Like both the UI and the backend are running in Spin, and then we are calling into the AI inferencing service, and then the key value store, both of which can run locally, can run in Fermyon Cloud, can run in like your Kubernetes cluster or wherever else you might want to run your spin application. And so up until this point, if we have a look at our spin.toml, we actually had one more component, and that was the key value explorer. So let's have a look at what was happening there as well. Key value explorer is basically a way for us to quickly visualize the state of the key value storage. So when was Finchi born, and I start a new conversation, basically if I refresh the key value explorer, I should be able to see the state of the conversation. And this is what we built last week. But then this is persisted in the key value store. But if I delete the conversation ID and I refresh my key value store, that's gone, right? Because we want to make sure we delete everything from the key value store. So these are the three components in our spin application right now. The front end of our app, literally just a web directory that has a couple of like HTML, CSS, and JavaScript files. Then we have the API, which is the TypeScript component that implements our API endpoints to generate a new message, to get the conversation ID, to delete the conversation ID. So if we look at the components, the source of this component is in the API directory, and it is built using the npm run build command. So if we look at the package.json file for our spin component, for our component, it's basically using Webpack to put together all the generated code and generate the WebAssembly module for us. And then the actual source code for the component is a simple TypeScript component that uses the Spin SDK for JavaScript and TypeScript, and it has the API endpoint for get, which gets the conversation history, and then the delete API endpoint to delete a conversation ID, and then the generate API/generate endpoint that takes in the user prompt and then continues the conversation ID. So that's the API component that we've had so far. All of our functionality on the backends has been implemented using TypeScript up until this point. We are going to use Rust for today's component. And then lastly, as I mentioned, the KV Explorer component that lets us visualize the state of the key value store. So we have the web UI, we have the generate post endpoint, we have the get conversation ID and delete conversation ID endpoints. We're now going to focus on building the endpoint to generate the conversation summary. So as I mentioned, we're using Spin. So if you go to github.com Fermyon Spin, you'll find the open source project that we're going to use. And today we're going to use Rust to create a new component. So let's go through that process. If you want to follow along, you can find the documentation in developer.fermyon.com. You'll find, if you go to the Spin documentation, on the language guide section, you can choose whether you want to build. You can build this component in Go, you can build it in Python, you can build it in JavaScript or other languages. We're going to do Rust because Rust happens to be one of my favorite languages. So if you follow through the prerequisites in the documentation, you'll find the instructions on how to get started from scratch. So let's do that. Spin has a couple of commands that lets you get started with a new application or extending your existing application with new components. We've used Spin New in the previous, like a couple of streams ago, to just create the application from scratch. And essentially, Spin New just creates an entirely new application for you. Today, we're going to use Spin Add, which helps us use existing templates to create new components to add to our application. So our application currently has 3 components. After we're done with the Spin Add workflow, we should have another one, and it should be pointing to a template for HTTP Rust that you can find on GitHub as well. So every time you do a spin new or a spin add, you can find the resulting scaffolds for your application, for your component on GitHub on the template. So,
and Radu, I want to ask you a question here. So
sure.
when you do a spin new, you see like HTTP Rust and HTTP Go, and when you do a spin add, you also see the same things. Now, is that code base the same? Like, what is the difference between adding that particular component versus a spin new and a spin add?
Yeah, the quick difference, the simple difference between the two is spin new assumes you don't have an existing spin application, so it will generate the spin.toml file for you. Basically, the scaffolding for this, like application version and authors and name and version and all of that, and add your component. Whereas spin add assumes you have a spin.toml, you have an existing application, you have all this metadata, and it will just add your component. So once we're done with the spin add process here, we'll just see another component at the end of our spin.toml file. Both of them use the same templates. So if we'll have a quick look at HTTP Rust template, it has some metadata, which basically defines what spin new generates for your spin.toml file, and then it has a snippet for just the component. So if you dive into the templating engine behind Spin, you'll find how this functionality, what's the logic behind, what happens when you do an add, what happens when you do a new. But the idea here was to support both the workflow where you structure applications as entirely separate spin apps, or you have different endpoints under the same spin application. So that's the idea behind having both. It's a way to enable the flexibility behind both patterns of building applications made of multiple type of components. So cool. So we'll just do spin add, and it will walk us through the same process that we've seen when we did spin new before. So we're going to choose HTTP Rust. We're building an HTTP handler, an API endpoint using Rust. It asks us for the name of our component. Let's just call it summary. We don't give it a description, and then it asks us, there is an existing application, and there are some routes and some API endpoints in this application. What is the HTTP path? What is the API route, the API endpoint that this particular component should handle? So I'm just going to, I want it to handle, if we go back for a second to ExcaliDraw, I need to handle API/summary. And so API summary, and then there might be things here that we want it to handle. So I'm just going to give it a wildcard pattern so that anything that matches /API/summary is handled by this component. And if we go back to spin.toml, we now have a new component in our spin.toml, and it has all the setup required for Spin to be able to actually run this component. So things like, where's the wasm component file that this component needs to handle? What is the route that we just defined? And then how does Spin know how to build this component? So
nice. And yeah, for folks just joining in, this is Live Code Tuesdays. Radu and myself, actually mostly Radu, is building a serverless AI inferencing app. We've built a bunch of things already. And today we are building a Rust component, which gives us like a quick summary of the chat or the questions that you've already asked this large language model. Feel free to ask your questions in the chat, and also let us know where you're viewing this from. I think last time we had like a very, very global audience, so I'd love to see where our audience is viewing in from today as well. And if you have any questions, yeah, just put it in the chat. It can be something basic, advanced, whatever. If you just want to say hi, now is your time. Yeah, Radu.
cool. If we look at all the components in our spin.toml, some of them have the component build section, some of them don't. And I think it's worth diving a little bit into where that's coming from, what actually happens behind the scenes. So some components have a component source that is a URL, and some of them have a component source that is a relative file path. So what happens here? So what's happening here? So let's look at the first component. So the first component is called, it has an ID called web, and the source for this component is a URL pointing to a GitHub release. So let's go to that, github.com, file server. And this is a pre-built component that helps serve static files. Literally, you point it to a directory, and there's a WebAssembly module that whenever you try to hit a path that matches the file path, it will, the WebAssembly module gets instantiated, reads the file, sends it back to you as an HTTP response. So if you've ever used the static web server, that's exactly what this component is. But you've built it once, and we really don't want to like re-implement it every single time we want to use it. And so in Spin, you can point a component source to be just a file that gets downloaded from an HTTP endpoint. So in this file server, we basically have a GitHub release, and that GitHub release has a static file, a WebAssembly file, a WebAssembly component that we point to. And so instead of having a file that we build, WebAssembly component that we build, instead we point to a GitHub release for a WebAssembly file. And in this case, we actually verify the content digest to know that it matches. But for this component, for this web server component, we don't build anything because this component is already built, and we download the Spin static FS WASM component whenever we start Spin for the first time. For the second component, however, the source is a local file path. And so if we look at our ls API/target, we see that there's an api.wasm file here. And this is the file that Spin loads and executes whenever there's a request matching this route. And so because this is something local, because this file is local and usually don't check binary files into source control, or you need a way to build this. In particular, if you're working on this component, if you're working on this application, there's a mix of pre-built components that you're using and components that you are writing from scratch. And in this scenario, the API component in TypeScript is something that we're writing from scratch. And so Spin has a build command that will just iterate through all of those commands, all of the component build sections in spin.toml, and just run the build command. So it will go through the first one, and in this case, it's npm run build. In case of our second component that we added, like the second source code component we added, this is a Rust component. This is just going to invoke cargo build, which is the native Rust toolchain, and it tells it to generate a wasm32 WASI component. And so if we look in the summary directory, ls summary, there is no target directory yet because we've never built this component. And so we can just call spin build, which will iterate and call in order npm run build, and then cargo build target wasm32 WASI. So if we do a spin build, it calls an order building component API with npm run build, and then building component summary with cargo build target wasm32 WASI. This now invokes cargo and the Rust compiler. And by the end of this process, we should have a summary.wasm file in summary targets. So if you go to ls summary target, we have a summary.wasm file, which whenever we're going to run spin up, this will basically be invoked. So we've done
Radu, I
spin.
have a question here.
Yes, please.
And this isn't even one of those, I actually don't have a question, but I want you to answer, but I genuinely don't know. But it just struck me, what if the root is repeated, right? Like say in the first and the second component, you use the same root. Is there a hierarchy in a spin.toml which is chosen earlier?
Yeah, I think the algorithm for routing is longest matching route. I think is essentially, and it actually is duplicated here, right? There's a
Right.
slash API and something that catches everything, and then there's slash API slash summary, which hopefully is going to get caught by the Rust component. So
Got it.
it's the longest matching route that gets invoked.
Cool, cool. Okay. Yeah, I mean, I actually genuinely had that question. I see a few folks have just joined in. Yeah, folks, thanks for joining into our stream. This is Live Code Tuesdays. We're both from Fermyon, and we're trying to build an app with serverless AI inferencing. And today, we are continuing on an app that Radu's been building by adding a Rust component, which summarizes the chat that you're having with a large language model. Radu, so you just added a Rust component, correct?
Correct. I just added the Rust component, and now we're always gonna just have a look at what's happening here. So if you're just getting started with Rust, this is the entire spin component. It's one function called handle summary, takes in a request, returns a response. And whenever we're going to build this gets built into a WebAssembly component, and then spin invokes this component. So we did spin build, and it finished building all spin components. Now we can do a spin up, and ideally, if we do a curl localhost 3000 API summary, we should see hello Fermyon, which is coming from our Rust component. And then let's update this hello live stream spin build, because we have to compile our application, and spin up. And now it should be hello live stream. So we have a functioning Rust component that we can work on. There's one more thing that I'll do. So we've seen spin new, we've seen spin add, we've seen spin build, and we've seen spin up. I think a couple of streams ago I showed spin watch, which is another command that just looks for, watches the file system for changes and just recompiles and restarts the app. And that is so helpful when developing and when iterating through an application. And there's a component build watch field that you can specify what files should be watched for changes, and whenever any of those gets any changes, spin will run spin build and spin up again for us. So in case of our TypeScript component, any file ending in the TS extension will be watched. In case of our Rust component, it's cargo.toml and any .rs file that we might change. So instead of me doing spin build and spin up on over and over again, I'm just going to do a spin watch instead. And there's one more trick that I'm gonna use that I used last time as well. This is a way for us to run our application locally, but instead, specifically when using things like language models and inferencing and AI operations that would really require a GPU. If you don't have one on your machine, or if you just want to integrate on something that runs faster than what your machine can do, you can run your application, the entire application locally, but when there's an inferencing request for like an AI operation, that gets executed in Fermyon Cloud. So I'm going to just do that because my computer would get quite overheated and quite unhappy with me running a lot of AI operations on my machine. So Spin Cloud GPU is a plugin that just creates the connection between your application that runs locally and the serverless AI inferencing in Fermyon Cloud. And so it generates all the configuration required for you to do that. So I just did that earlier today, and I'm just able at this point to run spin watch. So let's see if that works. Let's make sure that hello live stream spin watch works.
Yeah, folks, do
And
check out
so,
the Spin Cloud GPU. Very, very handy little plugin to build your apps locally, but test out a large language model that's running out in the cloud. You can do it so much faster and iterate so much more faster on your app. Also, again, hit us up in the chat. Let us know if you have any questions about anything that we're talking about right now. We'd be happy to answer them.
okay, so we have the entire setup running locally. We've gone through what the app does. Let's start generating summaries for conversation IDs. So as we do that, let's have a quick look at our existing API endpoint, the UI, the web, the static web UI, and our first API endpoints that we build. They pass and forth a couple of JSON objects. One of them is a prompt, which is basically a turn between, like, a user says, "When was Da Vinci born?" That's the role is the user. The content is the actual message content, and then the assistant generates another type of response. That's another prompt, and so every conversation has an ID associated with it and a list of prompts. And so this is the type of object that we're passing between the front end and the back end. And so our Rust implementation, our Rust component, will most likely need to just understand those objects as well. For today, we're just going to serialize and deserialize those in Rust as well, using Serdi, which is a popular serialization library in Rust. In a future live stream, I think this would be a pretty cool example to show how we could use the component model to pass those objects back and forth, and to just avoid having to implement all of those every time. So I'm just gonna cd into the summary. This is the Rust component, and I'm just gonna add Serdi JSON, which is, as I mentioned, is the Rust serialization and deserialization library. And in particular, I'm using the derive macros that we're going to make use of in a second. So we are going to quickly keep the JavaScript implementation and the Rust source code file side by side for a bit, as we're just defining the structs that we're going to use for prompt in history. So just going to build a struct for prompt, and then struct for history. So a prompt has an ID, which is a string. It has a role, which for this example, we'll treat it as a string. Ideally, this would be an enum, because there are, like, the role can be, in our application, can be system, assistant, and user. So it would be really well suited to be an enum. We're going to go with string for now, because we never actually have to determine which one in this component. And then content, which is a string as well. And then history just has an ID, which is the conversation ID, and then a list of prompts. So we're going to represent that in Rust as prompts as a vec of prompt. Okay. To get some really convenient Rust magic and Serdi magic out of this, we're going to automatically derive, serialize, and deserialize, which will let us just automatically generate code to serialize and deserialize our prompt and history objects. I added the new library after I started my IDE, so I need to restart the language server. Really, really boring and not really important. So we can serialize and deserialize our prompt and history, and I think we'll most likely need another one just for, like, the summary that will contain the ID and just summary for an entire conversation ID. So let's just define that as summary ID as a string, and then summary as also a string. Okay, so at this point, we should have all the required objects that we would pass around back and forth between the front end and the back end, and most likely we don't need to have the other the TypeScript implementation side by side. Okay, so the way we want to build our API endpoint is we want the UI to just send us the conversation ID, and for our new API endpoint to just return the summary of that conversation ID. So what would need to happen is get the conversation ID from the request, load the conversation history from the key value storage. We need to deserialize that into a history object, and then we need to take the history and make a large language model request to generate the summary, and then return the summary. So that's largely what we need to do here. So I think we have all the setup required to do that. There are two specific things, or one specific thing that we need to do before our Rust component has access to any of the data that our application deals with, and that is defining that the component has access to the key value store, the default key value store that we've used in our TypeScript implementation. So the TypeScript as the TypeScript component, our API endpoint just use the default key value store in Spin, which is available by default with every Spin application wherever you run it. So it has to be declared that a component can access this key value store. And then our component also used the LLM feature, and it tried to use the Llama 2 chat language model. And so that also has to be defined. So the API component, the TypeScript component that we've built before, can use the Llama 2 chat model and the default key value store. We need our components to access the same because we need to fetch the conversation ID, and using the conversation ID, fetch the entire history from the key value store, and then take that history and send it to the language model. And so our component needs to access both the language model and the key value store. So
nice. Yeah, again, folks, just joining in. Just let us know where you're viewing this from. We've built quite a bit actually in today's session and in the two sessions that preceded it. So we're building a Rust component, which gives us a summary of a chat with a large language model. So Radu is just building this out. And yeah, just let us know what you think if you're using WebAssembly currently, if you're evaluating it. If you need to know anything about WebAssembly, put it in the chat, and we'd be happy to answer it for you. Radu?
Sure. Cool. So we need to be able to reason about what's the HTTP method for this request. What are some path parameters for this request? So Spin has a few helpers to simplify how we do that. We're going to use the router from Spin from the Rust SDK, similarly to how we used it in like the TypeScript API. It's a really similar API. So we're just going to do a router dot. We need to handle a post component for this endpoint. So we're just going to do router dot post, and then we need to specify the path for this, and then what is the function that handles this. So let's see, what does this look like? So it takes a path, which is a string, and then a handler, which is a function that takes in the request and the parameters and returns the response. Cool. So what we need at this point is the make the compiler happy for now. And then what is the function that will actually handle our post function? So let's call that, let's give it a name, generate summary or something. It takes in a request. By the way, if you're interested in learning about this, there are a couple of examples in the spin repo that in this specific scenario that use the spin router. So if you're interested where that's coming from and how to use it, how to use the router in Rust, there are a couple of examples here. We're just going to basically create something really, really similar to this. So a function that takes a request and parameters and returns the response. So request params a result of a okay. So for our function, our post endpoint needs to handle API/summary, and we need to if we go back for a second to our diagram, it needs to receive the conversation ID as a path parameter. So we're just going to define that as a path parameter. And then the function that we want to be executed here is generate summary. Define that function. And now we need to tell our handle summary component that router.handle and pass the request. And so this is hitting into an excellent point to talk about.
Do tell.
Rust. Yep. Once you define a Rust variable, it is immutable unless you actually specify that it can be mutable. And in the way the router is built in the Spin SDK, this is a function that takes a mutable reference to self, which means we can only have the setup if we define the router as mutable. So that's if you follow the examples in the documentation, that's pretty clear, but it's great to have like the rapid feedback. And I love the Rust compiler. It tells me pretty much immediately that you cannot mutate an immutable variable, and it tells you what you can do to fix that. So Rust is, the compiler in Rust is really, really great. So if you learn to actually understand and read the error messages, please, I highly recommend you do that. So this is what our actual handler component looks like. Defines the router, defines the method to be executed for /API summary, and then handles a request. And then this is the skeleton for our generate summary function. So this has to get the conversation ID from the request. If we go back to the example, that's exactly what the example shows us. So this defines this parameter, and then this is how you get it from the params. So let's do that. Let ID equals params.get, and it tells us what is the key for our parameter. What is this? This is an option of a static string. What this tells us is this can be none. It can not exist. So what do we do if it doesn't exist? Well, I'm just going to use anyhow context, which adds the error message that I'm going to write here, and then returns the error case of the error variant of our response, of our result. So cannot get conversation ID from param. Okay, so this should be a string at this point. Yep. Okay, so what we need to do now is, if we go back for a second to our TypeScript component, open the key value store and try to find the conversation from the key value store. So how do we use the key value store in Rust? key value store using key value store from applications. And we have examples in Rust. So define the store, and then we have functions like get, set, get JSON and set JSON. Where are those coming from?
Holy Odin says, time to learn some Rust. Completely agree with you, Holy Odin. So I think I was in the same boat as you up until very recently, because I had never used Rust, and then I started using Spin. And now it's given me a chance to sort of catch up on some of the basics of Rust, right? Like the type safety, the memory, and all of that. Still very much learning, still very much a Rust noob. But learning Spin has given me a chance to, look a little more into Rust. So, I think that's a good way, perhaps. When did you start learning Rust, Radu?
I think it's around 2018, maybe. So a few years ago at this point. If we go to the language guides in the Rust documentation for Spin, we now have a couple of helper functions that lets us serialize and deserialize objects from the key value store. So Rust has something called features for libraries, and the Spin SDK for Rust defines such a feature called JSON. So we're just going to open cargo.toml for this and just define that feature. Features.
Actually, we have an interesting question, Radu. So
Yes.
Holy Odin asks, can we use Spin for building CLI apps? I was thinking about making a CLI using the LLM kind of chatbot using CLI. So Holy Odin, just for me to understand, you have a chatbot that runs in a CLI that is request response, and the responses come from an LLM, right? Radu, I mean, that should be possible, right?
I think the Spin inherently helps you build serverless API endpoint and handlers and web applications and applications that respond to certain events. I think what you would need to do is, like, Spin's architecture is entirely pluggable, and it can be used to generate an application that responds to CLI commands. That's definitely possible. But the way Spin works today is it assumes that by default, it will generate an API endpoint for either whether that's HTTP or some other type of endpoint. But by default, it expects an API for you to write an API endpoint. So if you're assuming that you would build the CLI to run locally and then talk to an API endpoint that runs as a Spin application somewhere, whether in your own infrastructure or in Fermyon Cloud or in Kubernetes somewhere, and whenever there's an inferencing request from your CLI that gets sent to the Spin application, that could definitely work. Alternatively, if you're interested in making Spin work really well with CLI applications in general, I would recommend you have a look at the trigger implementation in Spin that lets you define and plug what type of event generates a Spin application.
And I was just thinking, Radu, so we have also, in our past couple of streams, we have spoken about how we can cache the result of a question to an LLM using like a KV store, right? So given that this is a CLI thing that Holy Odin wants to build, I'm assuming many of those requests are potentially similar. So maybe that can be cached in the local app itself, or the local CLI app. So the call doesn't have to go to the LLM, maybe?
Oh yeah. If you're okay with having an API that runs locally on your machine or somewhere else, and then the CLI talking to that API, the Spin application itself can do things like caching for your requests and generate embeddings, and basically you can use it in any way you would like. Specifically, like if you take this sort of application that we've been building live in the stream, this happens to have a UI that the user experience is a web application. there's nothing stopping us from building another sort of client for our API that is a CLI, but still the architecture would largely look something similar to this, right? In which the backend runs somewhere on my machine or in a cluster or in Fermyon cloud. And then the UX, whether it's a web application, whether it's a CLI, talks to it back and forth. That's definitely doable. And you can take advantage of all the things you can do in a spin application as well.
Yeah, Holy Odin, yeah, dude. I mean, if you want the source code for what we're building, it's on Radu's GitHub as well. So, and you can follow through past couple of streams. But yeah, man, would love to hear when you actually go ahead and build this, and potentially you could also put this up in our SpinUp Hub. So the SpinUp Hub essentially is a hub for things like templates and plugins and so on. This is the link, yeah. So if there's something you want to contribute to the SpinUp Hub, yeah, feel free. There it is. That's the SpinUp Hub.
Yep. All of the templates and examples and samples and libraries that we've seen so far are part of basically part of SpinUp Hub. So the static file server template that we've seen so far, you can find it here. The key value explorer that we're using, you can find it here as well. And then there are a whole bunch of samples that you can just use as a starting point for your application. Okay, so
sorry, Radu, but Holy Odin actually said I've done half of the first stream, so that's very heartening to hear, Holy Odin, because yeah, it just makes us feel nice that people are actually following along. So yeah, thank you so much for doing that, and thanks for just watching.
Nice. Thanks for watching. Would love to get your feedback on how these are going. Cool. Yeah. So we've opened the default key value store, and now we want to use the ID that we've just gotten from the request to just essentially use it as the key in our key value store and retrieve the object that we have from there. So the key value store, the KV store, has a bunch of some functionality that you can use, things like get or set, exists, delete, like functions that you would expect in a key value store on a non-relational key value store. There are two really utility functions that we've added to the Rust SDK, and those are deserializing your value directly into JSON, from JSON into an object, and then serializing it from your object into a JSON. And so we're going to use the get JSON function in here. So we're going to define a variable. We're trying to get the conversation history. Let history, and we're going to define the type for it. I'll talk in a second why. And we're going to do kv get JSON, and we're going to use the ID as the key. So why did we define the type, and whereas we haven't defined it anywhere else up until this point? Well, first of all, let's see what happens if we don't. Doesn't it contain, really? Yeah, it doesn't know what the type is, because get JSON expects that it's the argument that we're gonna use it with implements deserialize, which is the thing that we derived earlier here, which says this type, in our case the history type, can be deserialized by SERDI, which is the serialization and deserialization library. So if we removed the deserialize type, it would error out. And so using the history and give it the deserialized type, if go back here for a second and delete that, it should complain because deserialize is not implemented for our history struct. So at this point, we should have the history as JSON here. And so what we need to do right now is somehow format it in a way that we can send it to the large language model. So let's have a look at a few examples in so far where we've used the LLM inferencing feature and see how do we have to generate the prompt and massage our content and our data in a way that the language model understands what it is that we're talking about and what we need to generate. So Llama 2, if you look at the model card on Hugging Face or anywhere else, has this pattern in which you have to define the system prompt with what is this, what am I, what is the task that we're trying to do with the language model, and then you can give it a few examples. This is called few-shot inferencing, in which you give some examples and the expected response for that example, and ask it to replicate that for future examples and for future prompts. And so we're not going to use this one as it is. I'm just going to use this as a starting point, for our prompt. So what we need to do is the system prompt is, this is a bot that generates summaries based on conversations. So let's just say that you are a bot that generates short summaries for conversations between a user and an AI assistant. I think this is largely going to work.
Yeah. I mean, I guess the other things are, about like a code of conduct type thing, which
is possible. Yes, if there are any other things you want the language model to use as a guideline when generating responses, those should go there as well. And now we should give it a few examples of what this would look like. So I played a little bit around with this earlier today, and I generated one that I've seen works reasonably well. And so I'm largely going to use this one for now, and we'll just go through it really quickly. So similarly as earlier, you're a bot that generates short summaries for conversations. Summary should be as concise as possible, and then it should follow the pattern for the following examples. So this scenario, in this case, the question was, when was Da Vinci born? And other questions about Da Vinci. Ideally, the summary would be something along the lines of the life and career of Da Vinci, and then another one about the climate of California. So all I'm saying here is this is what the summaries and the titles should look like, largely based on this kind of conversation. So hopefully this is the type of example of the type of response that we're going to get using this prompt. So, and then now we need to take our conversation history and format it in a way that follows this pattern. So we have the history now. So what we need to do is remember, history has an ID and then a vector of prompts. We have to iterate through all the prompts and then add to the generate a prompt here and add to it. So let's generate like a prompt variable. Let has to be mutable. Essentially, create a new string variable, iterate through every prompt, and then append to this prompt variable. So for in history.prompts, which is the list of prompts in our conversation history, what we need to do is just append to that string. So prompt dot push string, which lets us concatenate our existing variable with like append new data, and then use the format this complains because it expects an own string, and now we need to we need to format the prompt in such a like user and then message or assistant message. So this would be p dot role and then p dot content. Cool. And finally, we have the list of user assistant exchange, and now we need to replace the history placeholder here with the actual prompt that we've constructed so far. Mm-hmm. So I'll let prompt equals place, and we have history, and we want to replace it with prompt. That's it, borrowing. We have borrowed. Cool. We now should have a prompt that follows this pattern here. And the last step here is we are going to use the LLM module and the Spin SDK for Rust. Let's search for language serverless AI interface in Rust. How do we use that? There's a function, infer with options, and that's how we generate an inferencing request from Rust. So let's just follow that. LLM, infer with options. So the inferencing model, llama 2 chat, the prompt, the one that we just defined, inferencing params, and we need to actually define what do we need here. We need to restrict the number of tokens that this generates, specifically because we want to display that here and we don't have a lot of space. So we're just gonna max tokens. I don't know. Let's go with 50, and then we'll make some changes.
And Radu, again, can we remind our viewers what like a token here is? Only because I think in the context of AI inferencing, you read that so much, right? Like a token. So in this context, yep. What would a token indicate?
Yeah, a token, like the way a language model represents text data is by having a numerical representation of every word. And so specifically, every word gets broken down into this sort of token from a vocabulary. And basically, it's chunks of words have specific IDs that a language model understands. And so, for example, in the language model representation for a specific word, a word is made up of multiple tokens. And so language models generate these tokens that are then put side by side. And so here, all we're doing is they're saying, don't generate more than 50 tokens. The response might be lower, like there may be fewer tokens, but this will generate the maximum number of tokens, in this case, 50. So at this point, we should be able to send the inferencing request to our language model. Spin will handle that for us, and now we should get a response. and print line, let's just print line the response and leave it at this for now and actually test something to see whether this does anything or not. So this function expects a API summary conversation ID. So we're going to test with curl, and we're just going to have to send a new conversation ID. So let's just create a new conversation. When was Vinci born? How old was he? Okay, we should have a conversation. Go to the key value explorer and copy the conversation ID. We have to use that as a parameter to our curl request. Post localhost. Our application is running on localhost 3000 API/summary, and we need to pass the conversation ID. And so ideally, this will execute our function. So let's see what happens. Ooh, something happened. There's an error, but that might just come from this to do here. So let's not lose hope just yet. So cool. So ideally, let's go through what should have happened. Generate summary. We get the ID from the request. So API summary and then a conversation ID, and we get the ID for it. Open the key value store and get the entire conversation history. Iterate through all the back and forths from the conversation history. So for every prompt, construct this back and forth, and then prepare the prompt that we're going to send to the language model. In this scenario, a system prompt telling the language model the context that we're operating in, and then using few-shot inferencing techniques, a couple of examples of what the model should do. And in this scenario, apparently we used the exact same user prompt, so we're going to have to test with something that's not specifically this. So let's do a couple of things. Let's log a little bit here so that we know that things are happening. Print line sending prompt to LLM. Okay. And then receiving the response. Cool. And then we want to just return a summary back, which we've defined earlier. So let's just do that. Builder dot status 200, and then body, we need to return sum. Let's just create a new variable for that. Let summary equals, we need to serialize, and then summary and let Rust Analyzer do that for us. We have the ID. We'll have to get back to that in a second. And the text, the response from the language model, and the text from it. No text. Oh, we need to get the result out of that. Now there's a text, and Rust is complaining because cool. So we serialized our summary. This is just using SERDI. Create the summary and then type constructed. What's wrong?
Some type error, I'm guessing. Yeah.
Yep. We are generating result of a response. Found enum results. Huh. Oh. Okay, let's try that again. That's one of the confusing parts of the Rust SDK that hopefully will go away and will get better soon. HTTP response builder. And then we status 200 and then a body. The body is an option. Huh. Oh, is it? Yes. No, it's not that. Arguments to this enum are incorrect. Type constructed HTTP response. Oh, yep. Yep. This returns a result, and we have to handle that result. And so at this point, let's try that again and see what happens. We should now print the prompt before sending it.
Nice.
Cool. Okay, and this is the summary. Leonardo da Vinci's life and career, including his birth date and age when he painted Mona Lisa. That's quite the large response, but that's fine. Well, we can tweak that in a bit. So we got the conversation ID from the request. We loaded the history from the key value storage, deserialized that, took the history, sent in a large language model request, returned the summary. The last thing we have to do is update the UI to actually request that and call that API endpoint. So what we need to do is update this title here. So let's just make it slightly smaller based on how long the response was. ID, let's give it an ID. If you're expecting any fancy JavaScript front-end techniques, don't. Summary. This is not even jQuery, plain JavaScript, and it's fetch. In a future stream, we might get someone capable on the front end to help us
do a 6-hour stream on only
here.
CSS. Just
Yes.
padding and
So there's a function called send message to the API that gets called whenever we press the send button. And so what we want is after we have our first response, take the pair request and response, the user and assistant message, and send that and generate the summary. So let's await fetch API summary, and we need to do this, pass the ID. And the other thing we need to do is, this is a post method post. Okay. Let summary equals our API endpoint returns a JSON containing ID and summary. And so we're going to do await s.json to read the response as a JSON, and then summary. Oh, we are shadowing a variable. Text. Summary is the HTML element. Inner HTML equals texts summary. So ideally, after the first request, okay, let's try this out. Let's try this out with something new. Okay. When
we got a nice comment, Radu, from Fly, who says, "Hi again, thanks for the live stream. The troubleshooting is super useful. Runtime errors from Rust and Wasm can be cryptic." Yeah.
Yep. And we
just on cue. Yeah.
Yep. What happened here? Clearing history, failed to deserialize response for post/index. That doesn't seem right. Text, okay. Inspect. Okay, let's try again. Is a word. Okay, there we go. Unexpected, uncut promise. Okay, let's look at a network. Yep, we have a broken, we didn't format the request properly. There's a missing slash right here. Okay, let's try again. Do they fly? Birds. We now have the quite succinct title. Yes. Let's try something else. What is the climate of the UK? The climate of the UK, okay. Does it rain often? Let's see. Okay. And basically every time we send a new pair of messages, we are generating, making a request to generate the summary as well. So, cool. I think we've managed to generate the summary properly. There are a bunch of other things that would be nice to do, like store the summary in the key value storage, because the first time you get to a page, you don't have it, and so it's only generated after you send the message. So we could do something like generate the summary first time we get to the page, fetch it from the key value storage maybe as well, but in how much was it to write this in Rust? About 60 lines of code. This is respectable.
Yeah.
We managed to build an API endpoint that generates this in Rust. Uses the key value storage. We did a little bit of debugging of response types, and errors and result values in the Spin SDK and for the HTTP objects. Side note, if you're interested in that and making this better, we are improving the Rust SDK for Spin. There's an open PR from Ryan, like right now it's open. So this should ideally simplify how the types of requests and responses that we get in Rust and how to use those. So if you're interested in that, please give it a try. And yeah, next time I don't know exactly what we're gonna build, but it would be cool to explore, either dive a little bit deeper into the Rust ecosystem for WebAssembly, or explore a little bit of Go, depending. If you have thoughts and if you have a request for us to explore something, please let us know.
Yeah,
But
let us know in the
otherwise,
chat. Should we do more Rust and Wasm stuff? Do you want us to do another component in Go? Or just like do CSS for like a 6-hour stream? Maybe not that one. But yeah, either way, just let us know. Yeah, and we will be doing this every week at this time. So you'll see the thumbnails on our YouTube, so you can hit on the like, share, subscribe, whatever, or also just the notify. And yeah, folks like Holy Odin and Fly, thanks for joining in and staying with us for the entire stream. For the other folks as well, thank you so much. Radu? Radu's checking in the code into...
And Spin Cloud deploy. I know what we're going to do next time. This is kind of annoying, having to manually push and then manually deploy my app to Fermyon Cloud. So next time we're going to basically, and I don't know what's happening here, but next time we're basically going to...
I think you wrote deploy. Did you write deploy? You wrote deploy.
It might be. Yeah, next time we're going to write a GitHub we're going to use the GitHub action for Spin and Fermyon Cloud to add CI to our application, things like automated builds for our app, and then whenever we merge a PR, to deploy our application automatically to Fermyon Cloud. So that's what I think it would be nice to explore next time, to see how to add that sort of automated mechanism to our app.
Yeah. I mean, I think our viewers are very divided, because Holy Odin says Golang, Matt says Python, and Fly says Rust all the way. So, but we'll do this every week, so we're going to cover all of them for sure. Volkan, also thank you for joining in, and thank you for watching as well. Yeah. And Radu, any last words, or we'll see everyone next week, I guess?
Yeah. If in the meantime you want to make this better, check it out on GitHub, and pull request welcome. Otherwise, have a look at Spin. Happy to chat about your use of Spin and how you're thinking about using WebAssembly and Spin in our Discord.
This is our Discord. I know Holy Odin just joined our Discord, but yeah, if you all aren't on our Discord already, feel free to reach out, and you can reach out to us about how we could improve this live stream as well. Love to hear from you. Apart from that, that's it, I think, and we will see you next week. Thank you again, Radu, and thanks everyone. Bye.